Hi everybody. So we will be presenting Swiss robots with adaptive morphology, and this is the presentation of Cohen 1. I'm Siddha, and my friend Elena is here with me presenting. So first of all, we'd like to talk about the initial problem that we had been presented with, and Elena will be talking about the initial problems that we had. So.
Hello, this is Elena. I will tell you about the list of the problems which we want to discuss with you. The first is the ability to collectively adapt to the given box size. So we discussed this problem and tried some projects at the robots. The next problem is how the behavior of the robots can be optimized. Also, we tried to introduce some sensors or maybe another objects to the robots to check what will be. The next problem is how change in morphology and field type affects the behavior of the robots. So we also tried to change the environment and looked what will be. And the next, we think that it is very interesting. We try to explore how the robot's behavior can be compared with animal behavior or insects behavior. The next slide is the topics for consideration. I would like to tell first that some of the listed problems we only discussed, and at some of them we worked. So we tried to introduce something like animal behavior in robots to show how Swiss robots can it do. Also, we tried to introduce a slope on the project and watched what could it be.
So now we will be talking about the initial ideas that we had to solve the problem. So first of all, we thought about introducing optimum behavior, and one of the methods that is possible for optimum behavior is to use machine learning. And in machine learning, we thought about using adaptive boosting and grid search. So adaptive boosting is based on changing the weightage of each parameter with each iteration. So suppose in the first iteration, we have some parameters and their weights which support the result. So these parameters will be decreased in the next iteration, and vice versa for the parameters which are decreasing the result. Then we have another option as the neural networks, and this was suggested by our Chinese teammates. However, they're not able to make it today to the presentation. So what they suggested was that we should find and mark the cubes, and communication will be carried out amongst the cubes. And each robot will be knowing where the previous cube had been encountered at which particular grid location within the system. There was another idea of using the GPS systems, which is the global positioning sensor nodes, using a supervisor controller robot. The supervisor controller robot was used to guide all the other robots, telling them where to go and where the other robots have encountered a cube before. But since the Swiss robots are a basic form of robots and they do not rely heavily on communication, this idea was not quite feasible. Now, the machine learning methods that have been entailed while in robotics, these were supervised learning, unsupervised learning, and reinforcement learning. So first of all, in supervised learning, there were the labels present for the dataset, and the system had to tag each data with some label. Contrary to this, in unsupervised learning, we had to find the hidden structure in the unlabeled data, and because of absence of labels, there is no reward or error signal which can be used to evaluate the solution for this. In reinforcement learning, we consider the behaviorist psychology. It deals with how the software agents should take action in order to maximize the reward. and there may be some constraints present within which these software agents have to work in order to optimize their results. Now, Elena will be talking about the neural networks and the advantages that we found while working on the Swiss robots.
When we were working at our preliminary report, we discussed the idea of using neural networks. So, using these networks has some advantages. They are listed at the slide. For about ideas, what we would like to implement. It was an idea to implement the marking cubes and using the uh, neural network to detect what cube was marked. Also, one of the idea was to implement a neural network which could help to train robots to the case when the cube size were exchanged, so they could run into them with more force, for example. Could you list the next slide? At the next slide, there are an architecture of the neural network. We also talked about this architecture, but we didn't implement it yet, but we would like to do it. We discussed they had been learning to use while learning the neural networks. Here are the mathematical implementation of the network. Next slide, please.
So if we talk about the morphology of the robots, first of all, the Swiss robots, as we can see on the screen, these Swiss robots have their own coordinate system where the origin is the position of the main cluster point, and the current position is relative to the other cluster points, and this is calculated using the path integration method. While moving, the robots need to distinguish three things: another robot, a cube, and the wall. So based on the difference in the width of these three, they can distinguish the walls. And apart from the walls, they need to also distinguish between the robot themselves and the cubes, and this is done by the ability of communication. So if the other robot is able to start communication, the robots will know that the obstacle in front of them is another robot, else it is a cube. So this is another robot. Now talking about the distance sensors, the distance sensors are used as sensors for communication, and they inform the robot about which distance and direction to move in. Now there are several kinds of distance sensors. Some of these are proximity sensors, which are distributed over the front half of the robot, and each sensor is connected to a node in the neural network. We saw the proximity layer and the collision layer in one of the previous slides, and the collision sensors are present in the collision layer, and these are based on the binary threshold values, and they transmit only when a collision takes place. Apart from these, we also have the light sensors, which promote the movement of the bots in the direction in which the light falls. Apart from this, we also have the infrared and the touch sensors. Now talking about the cameras, we used cameras in the this. We have a video here also. We had used camera to help in vision among the robots, and so this is the video. These are based on locomotion, and for locomotion we base or using the infrared sensors. Using the infrared sensors, the age of the cluster is exchanged, while other robots are able to get the global and the oldest faster. And the other method is using the wheels. The wheels are driven by electrical motors, and both the wheels can either move in the same direction or opposite direction. If the wheels move in the opposite direction, the robot will turn on spot, and if they move in the same direction, the robot will be moving forward. So at the end of this video, the cubes will form a cluster, and the robots will will have formed it. So moving on to the next slide. We have robotics and animal behavior.
So we studied the problem of using animal behavior in robotics. So we think about the idea when the robots could be explained like animals, for about Swiss robots, and they are going for a hunt or for something else, for finding food. And they are searching at the field and marking the cubes, or maybe they see the cubes and they have some color, as at the example which Seta had shown you. Um, and then when they can run into the object, they could see if this object is of their color or different color. If this cube is has different color, they run away. Or if the cube of white color, they mark it.
So these are the cubes that Elena was talking about, the white, green, and yellow cubes. And the red, green, and blue are the Swiss robots that have been employed in the system. So Elena will be explaining this further.
Okay, this is one of the screens of the project. Here we try to make boxes of largest size. What we have seen, we saw that robots could harder move the cubes, so sometimes the moving of the cubes could be almost impossible. Here are some clusters of cubes which are marked of colors. Could you move to the next slide? Here are the example when we change the environment and introduce the slope. So when we introduced the slope, we saw that robots could harder get off the corners, and they could harder move cubes which are under the slope. Could you move to the next slide? Here are the video. Oh,
Yeah, this is a video. I'm just trying to play it.
okay, stay here. So this is the implementation of moving cubes and detecting what color of the cube has. So I tried to make two types of this project. One type you could see a few slides ago. There was only one robot, and when he ran into one cube, we could see on the console what color the cube has. So the next idea, which we would like to implement after the presentation, to make to mark cubes when we run into them.
So this is another video where we do not have the cameras or the vision applied to the robots. In this video, we can see that the robots are able to learn throughout the video, but most of the part is random. And after attributing vision to the robots, they are able to move at a better learning rate. And that is why we think that robotics has a huge amount of knowledge that can be derived from animal behavior, and that is what we were trying to do in this project. So in the end of the video, they're able to form clusters.
I
They're able to form clusters of the. So that is about all the work that we did in this session of the Shanghai lectures.
At the end, I
And
would
thank
like
you.
to say about the idea which we used implementing the project. We would like to take a spot of color of a different color in the middle of the screen using cameras and simply pass the image of pixels in the center of the image and then some of the colors of the color components individually. So we could know what color has the cube in front of the robot. Thank you.
Okay, thank you very much.
Thank you.
Thank you. All right. Thanks for a very nice presentation, guys. We had some issues hearing what was being said while these YouTube videos were being played, unfortunately. This is actually a good point since we're using Hangouts. Do you guys, could you try to just, this is just a quick test I'd like to do. There's a tool on the left-hand side bar called YouTube. Would you be able to find your video there and play it directly from there? For example, the last one, just as a test.
Yeah, let me try.
Because that would really be a nice integration.
So you were not able to see the video?
We saw the videos, but when the videos were running, your spoken, basically your speech started breaking up, so we can hear very well what you were saying. So I'm wondering if this is something we can improve by displaying the YouTube videos in Hangout for the future. That's an interesting test to do.
Let me try.
Okay. Okay, so we can just see a black screen right now.
Okay, just a minute, it's working.
Okay. Okay, we still can't see anything. Can you see something, Sida?
I think so. You should be able to see the video now.
Okay. It's
Or
still kind of just black here. So maybe it's not working properly. Okay, well,
okay, can you see it now?
no, I still can't see it. Let's just leave it there. You try, see if it comes on while
Okay.
asking you questions, basically. So,
All right.
Any questions from the panel?
Yes, I do have a question. Can you hear me?
Yeah.
Yeah, I can hear you.
To ask, did you have any experiments with changing the morphology of sensors of the robot? For example, moving them to different position on the robot. And if you did, what were the results?
No, we didn't change the morphology of sensors. We only used cameras.
Yeah, I see. Okay, thank you.
Thank you.
I have a question too. I don't know if it was because of the quality of the sound that during the video was not the best, but it is not clear for me what the role of cameras is in your system. I mean, is there a camera on each robot? Is there just a top view camera giving the positions of the cubes?
Yes, this is the camera on each robot, and we try to see the cubes which are in front of us.
Okay. And have you performed any kind of measurements of comparison between the first sensors and the camera, the performance in that case?
No.
Okay.
Okay, any more questions? Sida, have you got the YouTube working? Looks like you have something there. Yeah, if you try to play that one, let's see if we can see it.
Yeah, it should be playing.
No, I still can't see it moving really. So. Okay, well, doesn't matter.
I think we should try another. No, I think that probably she was able to share the YouTube video, but we are not looking at it in the right way, so we should study how it works.
Yeah, yeah.
I think because yeah, we are just seeing the screen 2 times essentially.
Yeah, exactly.
Okay.
But anyway, no, probably that's the right way to do. So to share the YouTube video by YouTube, but we need to practice.
Yeah,
Maybe.
everybody should use the YouTube app. I can now see the video that is being shared. I clicked on from the left myself also, and it asks permissions for using the YouTube app.
Good. So exactly, maybe. Okay, but this is I was trying because. Okay, we can try. We will try. But,
yeah.
It seems that that's the way to go.
Yeah. Okay. So I have one. Yeah, I have one question for you guys. So you had a real robot there. Was that something you actually built for this project, or something you used from before? And how difficult would it be to move what you've done in the simulation onto this real robot?
Yes, we really have the real robot. It is an Arduino compatible mobile robot kit. Oh, so we would like to implement not this idea which we show at the presentation. We would like to implement something connected with neural networks.
Okay, so something like the neural network you showed, the distributed adaptive control.
Yes.
Okay.
Yeah.
Okay. Any other questions or comments from the panel? You're all tired now.
No. Did you think a way to adapt more the real physical morphology of a robot? I don't know, to stick to cubes, things like that.
Oh, the real robot has touch sensors, so we would like to use these sensors to indicate maybe the heavity of the cube, or maybe running into the other objects which are more heavier than cubes. So we could train the real robot.
Mm-hmm. Okay, thanks.
Okay. So if there's no more questions or comments, I think we'll give another round of applause. Thank you, guys.
Thank you.